Konnichiwa. Watashi wa Andres desu. And welcome to Oracle Database Ecosystem for Java developers. As mentioned earlier, my name is Andres Almaray. I'm a Senior Principal Product Manager at the Oracle Database Group. Even though I work a lot with open source and code, I prefer to name myself as a seasoned sorcerer. One of the many things that I do as part of my job is reach out to developers such as yourself and let them know about the different products and projects that we have around the Oracle database. Now, Oracle is well known for a serious set of products. The database is the main one. Oracle Linux is another one, and of course the Oracle Cloud. There are, however, other tools that sit around these projects. And as a Java developer or as a regular developer, I could tell you many things about the Oracle database. But perhaps one that personally excites me a lot about the Oracle database itself, it's its capability to be able to host different formats within the same database engine. Say, for example, that your application is comprised of data that needs to be stored in relational model. But would you also like to explore document data stores, be it JSON? Or would you like to have a graph or geospatial or something else? Now, you will probably look out for different database vendors, different options where you will find what you're looking for. Yet the thing is, once you put all the pieces together, then there is a data store in one format, and there is another data store and a third data store, all different products, and you need to query among different formats. And yeah, it's doable for sure, but it might be a bit much easier if all those formats were to be sitting within the same engine. And that is what the converged database from Oracle provides. It's not the only one that does it, but we are sure that this is the one that does it in the best way. It has a lot of things that can be interconnected with one another. So in my experience, it gives you the best our experience out of the box. So just give it a try if you haven't seen it before. If you're just used to relational databases and are exploring into other formats, then the convergence database is definitely going to give you an option for you. Now, going back into Java. So there are different ways that you can talk to an Oracle database using Java tools. And the point of this session is to showcase a few of those projects. Some of them are available from Oracle itself. Most of them are available for free or open source. And there are other projects that are provided by third parties and other vendors. The whole point is to demonstrate how we can do more with Oracle technologies and Java technologies. To begin with, perhaps the most important change that happened in recent years is the immediate availability of the Oracle JDBC drivers from Maven Central. This happened back in September 2019. It was announced at Oracle Cloud World and Oracle Code One, September 2019. And the great thing about this is that before this change happened, you had to download a jar file from OTN. You had to abide to the license when you click a checkbox and said, yes, I am okay with this. And you will have to host the jars in a company-wide artifact repository if you wanted to have CI builds, continuous integration, or share with other team members. Possible, it was a bit of a hassle. But after this change, now you can consume the Oracle JDBC drivers just like any other open source or free dependency available from Maven Central. This means you no longer have to have a click-through checkbox or license acceptance. You just use an as is. And you just configure the dependencies, the gap coordinates, group ID, artifact ID, and version for a particular artifact in the JDBC drivers. And you will be able to use it in any kind of application. There is no other license restrictions, just use it as it is, just a regular binary. Now, there are a series of artifacts that we can choose from. And for this reason, we have created something that is known as the Developer's Guide for Oracle JDBC. Now, this document, by the way, you will notice on these slides, you will see a QR code appearing from time to time. If you scan this QR code, it will let you browse to the particular URL that I'm showcasing. So whether it's the one on the top or you use a QR code, there's always information for you to reach out. So this particular document will display all the different use cases and scenarios that are now available thanks to having the JDBC drivers available on Maven Central. If you just want to consume single jars or individual jars and POM files, or if you want to consume something that we call flavor POMs, these are POMs that allow you to consume multiple dependencies at the same time, or something that is also well known nowadays if you happen to use Maven, are the BOM dependencies. BOM stands for Bill of Materials. So I'm going to give you a few examples of how we can use each one of them. And depending on your particular use case or scenario, you will choose the one that fits your needs. So let's start with the most basic one. Let's say this is a very simplified version of a Maven application or a Maven-based application. And the only thing that it has right now is a single dependency. The dependency lists the group ID, artifact ID, and version coordinates, or GAV for short, for that particular JDBC driver. It's the latest version that we have at the moment. I think it's 21.100. And if you happen to use Maven to resolve the dependencies of this particular project, you can see the output right there in the console. We only have one dependency. This is what is expected. So you can browse Maven Central or your organization's artifact repository for any other dependencies or any other artifacts related to the JDBC drivers that may be needed for an application to work correctly. The other option that we have is called the flavor POMs. Now these POM files will provide additional dependencies that go together in order to fulfill a particular use case or a particular scenario. In the case of the OJDBC 11 production flavor POM, this brings all the dependencies that you need to connect to an on-premise Oracle database or to a cloud database like Autonomous Database. So the way that this works is that you import the dependency, or actually you declare the dependency as you would regularly do, but there is one extra bit of information that you need to configure, which is the type POM, which is what you see there in the red rectangle. Because you see, this particular dependency does not produce any jars on its own. It typically, Maven expects that for every POM file, there is a matching jar file. But flavor POMs don't have any jar files explicit to them. But what they do is that they group together other jar files. For this reason, we need to tell Maven, don't download a jar that matches the OJDBC 11 production name, because you're not going to find it. Instead, you have to find something that is a POM file. The great thing about this is that once we have configured a dependency like this one, notice that we resolve all the dependencies for our project, even though we have a single dependency definition. When we resolve all the dependencies, we have about about 10 or 11 additional jar files that become available. There are other flavor POMs. There is debug, there is observability, and depending on the use case, you would like to use one or the other. And finally, say that if any of these flavor POMs that we produce by default are readily available for to you in Maven Central, if for some reason they do not provide or do not comply with the use case that you need for your application, you either can create your own flavor POMs or you can use the BOM dependency. Now, BOM files, stands again for Bill of Materials, must be consumed in a specific way. If you look at the particular Maven POM file that we have here, we have a dependency management block where we declare our intention to import the OJDC BOM and that particular version, again 21100. Once we have imported this BOM, everything that BOM defines in terms of dependencies may become available to our application. Now, if you turn your gaze into the dependencies block, you see that we define two dependencies, one on the OJDC 11 drivers and another in the Universal Connection Pool, or UCP for short. You will also notice that we have not defined version numbers for these coordinates. But when we resolve the dependencies, when we look at the output in the console, we do get the right versions. And this is one of the reasons why we use BOM files. Because you see, a BOM file again is a collection of dependencies that go together. And if you instruct Maven to import said BOM file, what you're actually telling Maven is read all the definitions that are found in that BOM file. And if my consuming project, my application, happens to require any of those dependencies, then the BOM file can supply versions. It could also supply scopes if you needed to. But in this case, for this particular application, the only thing that we say in A is, hey, I need both driver and the UCP. I could define explicitly versions. I could define those versions using a property to reduce or to refactor duplication. But I could also use the BOM file, which guarantees me that everything that I import is part of the same group. In this case, driver and UCP. So no matter what scenario you are, in what kind of applications you're building, microservices, these kind of BOM files, simple, flavor POM, and BOM files should be enough to fulfill all your needs. Thanks to having all these different artifacts available in Maven Central allows third-party application frameworks to provide more benefits to you as a Java developer. There are many applications frameworks out there. Today I'm going to talk about 4 of them, which are probably the most well-known if you're writing command line applications or desktop web apps or microservices. All these frameworks will give you the option to build such kind of applications. Like choosing an editor, choosing one of these particular frameworks could be a heated debate. So I'm not going here to pitch to use one or the other. But if you happen to use any of this, then talking to an Oracle database becomes a much easier experience. Let's start with Spring Boot. The Spring Boot is probably one of the most popular application frameworks that exist out there. And there are a handful of ways that you can create a new Spring Boot application or a new Spring Boot project. The most common one is use this website called Spring Initializer, which besides letting you select which version of a Spring Boot you want and what is your main language, in this case I will hope that you will choose Java over the other ones, and the build tool of choice, Maven or Gradle. You can also select on the right side, click on that button that says Add Dependencies. And that will let you browse all the different features that the Spring Boot team has verified they work together with Spring Boot. It so happens that they support the Oracle driver. So when you create a project like this, and you click on the Generate button that is found at the bottom of the page, this will create a project with Maven and all the different settings. And if you inspect the POM file, you will see that there is a dependency to the Oracle JDC driver, but there is no version. The reason is that Spring Boot and all these dependencies consume the Oracle JDC BOM that I showed you just earlier. The version of the driver or any other Oracle dependency is managed by a Maven property in your POM file. So if you just want to upgrade or downgrade or simply change to a different version of the driver, you can specify one single property. This is known as a managed version, and Spring Boot does it for many of its dependencies. It so happens to support the Oracle dependencies as well. There is also the Quarkus framework. Quarkus, if you browse for the different extensions that Quarkus offers, this is very similar in the case as initializer, so it allows you to bootstrap a project with a particular build tool and a particular version of language. But if you browse to the extensions, which is what I did here, and just type Oracle, you will find two of them. First is the JDC driver from Oracle. So this is just the regular driver. And secondly is a reactive client for Oracle, which we will see in a moment. But the important bit is similar as the initializer. Once you have configured your project, you can click on the blue button that says generate your application. This will create a project, a zip file that you can download and start coding. The JDC driver version is also a managed property that you can change very, very simple. Then we have Micronaut, which is another application framework that does a lot of great things for microservices. Similar as the other two options that we have seen so far. You can select what is the version of the tool, what language you want to use, which build tool you want to use. And if you click on features on the left side, you will open a dialog that will allow you to select all different kind of features that the Micronaut team has tested that work together with Micronaut. In this case, I have selected two of them. Oracle, which is for the Oracle JDC drivers, and JDC UCP, so that I can use the universal connection pool, which works much better with the Oracle drivers than any other connection pool that is found out there. Once you have made all your configurations, you click on generate project, and you guessed it, you can generate a zip file with the project sources and then continue coding. The Oracle JDC driver is also handled using a managed property. So if you happen to choose any of these three frameworks, the kind of experience to get started, to get bootstrapping a project, and once you do, how you can update or change the version of the Oracle driver is very, very similar. Finally, we have Helidon. Helidon is a framework produced by Oracle. It comes with two flavors. One is standard Java SE and the other is SMP. MP is the one that allows you to use the micro profile set of standards. And it so happens to also support Oracle JDC drivers from the get-go. It has, like the other frameworks, the possibility to have a managed version of the Oracle drivers. This is why in this particular documentation page, we only see the group ID and the artifact ID. There's no version. It's already automatically managed by the framework. I believe the last time I checked, there was no website that will allow you to bootstrap an application, a Helidon application like the other frameworks. But there is a command line tool, there is a CLI tool for Helidon that allows you to bootstrap applications and handle dependencies. So that will be another thing that I would recommend you to have a look at if you happen to use Helidon. So in summary, for all these four frameworks, the important bit are that first, each one of these frameworks will manage the version of Oracle for you. The teams that produce these frameworks actively test every feature that is integrated in the frameworks. This means testing against the Oracle databases and ensuring that the chosen version that they manage for Oracle database or the Oracle drivers works with that particular version of the framework. So you can just rest assured that once you have made a choice for any of these three frameworks, building applications or microservices that talk to the Oracle database should be a straightforward deal. Moreover, what we are looking so far were access to databases using a synchronous option. That is, you issue a query and your application stops and waits until you get the result. Now, this is what we have doing since the beginning of JDBC API was available. But in the past, I would say 5 to 6 years, in the recent years, there has been a drive to be able to reuse resources in a much smarter way, if I can say that, such that it is hard and expensive to create threads in a Java application because you are bound to the size of memory and the process and the processor, a few other things. So it's not something that we can just simply say, oh, I'm going to create a new thread and forget about it, right? For this reason, this idea of reactive programming came to be. And you can use reactive programming in your business layer, in your client layer, but not so much in the database layer. So even if you created your whole application to be reactive, the moment that you talk to the persistence, the moment that you talk to the database, everything is slowed down because you're back into a synchronous way of work. Well, there are a few ways that we can get out of that. And one of the things is the Vertex Oracle client. So Vertex is yet another framework that exists out there that allows you to create reactive applications. And the team behind Vertex got in touch with us, with Oracle, and we collaborated together so that in the end result, what we have is this open source project called Vertex Oracle Client. With this, you can use a reactive set of APIs to talk to an Oracle database. Now, this will allow your whole stack from the UI, the business to persistence to be fully reactive if this is what your application requires. And this reactive client is what Quarkus uses to also expose that set of asynchronous APIs. But this is not the only option that we have. There is another set of APIs, which, by the way, this actually happens to be a specification. It's called R2DVC, and the website is r2dvc.io. And the idea behind this API is to fully embrace the reactive extensions or the reactive streams specification. The code that you see here, it's pretty much the same kind of code that you will see in a reactive application, whether you are in the business layer or if you're in a reactive client. Basically, what this thing is saying is, we're going to connect to a particular database. Notice that the connection string uses a prefix called R2DVC. And in this case, we're going to talk to, this example is showing how to talk to an in-memory database. But of course, it supports Oracle. I'll show that in a moment. And the rest of the instructions is just regular reactive streams set of APIs. So we can flat map, we can stream, we can consume, we can map, we can react to an event whenever there is a new event or whether there is an error or whether we want to continue, whether we want to tell the backend to wait because the client is too slow or it's the other way around. That's the kind of things that reactive set of APIs allow you to do. On the other hand, if you have not gotten into reactive APIs, let me tell you that even though they sound really cool and really interesting, once you get going and once you get in the process of testing, it gets a little bit trickier to do so. There is an Oracle JDBC driver or an Oracle R2DVC driver that works with this API. This actually complies with version 1 of the specification. It might be the case that Oracle was the first one to comply with version 1 that came out like last year in 2022. And this project is open source. It is maintained by a team inside Oracle. So if at any time you encounter any troubles, if you decide to test out Oracle R2DVC, you can browse to that particular repository and open a ticket and get in touch with the team that develops this API. And I mean, also given that it's open source and everything else that we have done so far, you can't have any problem. Just find the issue tracker and let the team at the other side know, hey, I found this problem or I encountered this issue. Can you help me? Even better, if you have the time and if there is no problem with licenses, provide a patch if you can do so. There is one more thing that should be discussed in terms of asynchronous APIs. You might have heard that there is a project called Project Loom that has been in works for the past few years. And it's now in preview mode since JDK 19 or Java 19 that came out in September of 2022. Now, one of the many things that virtual threads and Project Loom will provide is the capability of create what is known as virtual threads, that is lightweight threads. Instead of creating something that is heavyweight or expensive like a regular thread, we should be able to create as many virtual threads as possible, and we are only bound by memory. This means we are no longer restricted. We no longer need to pull resources so often. We can just simply create stuff as we need it. That will affect in some way the JDBC APIs at some point. Because right now, let me remind you, the JDBC APIs are synchronous, but once we have Project Loom fully integrated, no longer in preview mode, I'm pretty sure we're gonna see new versions of existing APIs, such as JDBC, that can take virtual threads into account and harness all the power and all the new capabilities that virtual threads will allow us to do. So keep an eye on this. If you are struggling for resources, asynchronous APIs like R2DBC and Vertex will probably help you right now, will help you today. But once we have the newer versions of the JDK and Java coming out, and virtual threads fully integrated, and new versions of the JDBC API, then you will be able to have much better control on how you can create all these different threads and resources and whatever else that is needed by your application. Now let's turn our gaze into JSON, because so far what we have seen is just accessing the database in a synchronous or asynchronous manner, but we're assuming that we're just talking to relational databases or relational format. But as I mentioned before, with the convergent database, we have multiple choices. JSON is one of those, and there is a project called SODA for Java, which stands for Simple Oracle Document for Simple Oracle Document Access, I think. And what this particular set of APIs allow you to do is that you can now store JSON and retrieve JSON from the Oracle database, even though your application, or actually your storage, continues to be relational. So the advantage of this is that now you have a mixed model. You can have relational data in your standard tables, and you can have JSON data in the same relational tables. Instead of using plain JDBC access to talk to that JSON data, you will use this API called SODA. Basically what this thing does is it treats your JSON data as a collection of JSON documents. So in this example, we can see that once we have initialized an Oracle client, which will, by the way, rely on the JDBC drivers that we saw earlier that are published in Maven Central. This API is also published to Maven Central. It's also open source and maintained by an Oracle team. So once you have created a collection, then you can add documents and you can query them, find them by key, find them by an example, and then retrieve all those values, do any kind of mutations that you want to. There is no longer a need to just try to fumble around with plain JSON format through JDBC. SODA for Java does this for you. There is also the matter, well, the database itself, right? So There are different editions of the Oracle database, Enterprise and Standard Edition. There is the Cloud Edition, and I don't know if you were aware, there is also the Oracle Database XC, which stands for Express, is a smaller version of the database, which can be used for free. You can download it for free and start using it for testing, for development, and even for production. Of course, given the limitations of this particular edition, the moment that you put this into production and you reach out to a much larger scale, then you probably have to look into the other editions. But let me tell you a few great deals about this particular edition and why, even though you might be using one of the others, the Standard or the Enterprise edition, why would you like to also have a look at Oracle XC? Specifically for testing. Because if you're using a Standard or Enterprise, you will need at least one instance to be shared among everyone that needs to do the testing. This will mean that now you have to ensure that the database is in a particular state for all these different test cases, that no one is writing to a particular space while tests are working on, so that there is no one that is doing something that shouldn't be doing. And even though it's possible, of course, that requires more work for you, for your team, and for your IT department. So what if you were able as a developer to simply create a database and start testing against it in such a way that you and that database do not collide with any of your team members, and you don't have to wait for the IT department to provision the new instance or the settings that are required for you to do the work. This is the thing that Oracle C allows you to do. You can use it as is, standalone, or you can pair it with another great project out there that is known as test containers, which you can use with JUnit 4 or JUnit 5 in order to have automated test cases. The advantage of using test containers and Oracle XC together is that you can create an instance of the Oracle database of Oracle XC as close as possible to your tests, such that you can guarantee you have a very clean environment every time that you're running a test case. So there shouldn't be any false positives because any lingering data or someone else was writing into a shared space. There is an Oracle XC model provided by Test Containers out of the box that you can use. There are a handful of examples out there. You can use the official Oracle XC Docker images provided by Oracle, or you can also use this particular image that appears right there. It's called Oracle XC from a GitHub repository called gvenzel. Who is this G. Benzel? It's actually Gerald Benzel, director at Oracle. And he is the one that has created, let's say, streamlined versions of what are the Oracle XC images. So this still remains as part of the Oracle sphere of influence. So this is not some random person that has been doing things and might get you into trouble because licensing or something weird with security. No. This is someone from Oracle that knows what he's doing and has produced a set of Docker images that you can use. And there are a handful of ways that you can use them. Just start Docker and then pass the version and the image that you want to use. Or you can also pass or launch a volume with an existing Oracle database so that Oracle XC will point to those files instead of creating a new one. That will make your boot up much faster. And depending on how you use this thing, there are a handful of scenarios. So let me show you some real use case usages of this API. By the way, this is the announcement back in the 2021, I think, when Gerald said, hey, there is a new set of Docker images that you may want to use. They're smaller, they make your test cases run faster, and depending on the use case, you might want to use these images or the official ones coming from Oracle. It's all good. So here's one use case if you happen to use GitHub Actions. You can use what is known as GitHub Action Services. This piece of code is a CI workflow for a project called Rife. Rife 2, actually, matter of fact, is another web framework that you can use to create web applications. As some of the features that this web framework provides is integration with databases, and Oracle happens to be that one. They need to test, or they need to ensure that what they are building is correct. So they need to test against a real Oracle database. So they use this setting called a GitHub Action Service, where you specify a Docker image and some settings. In this case, I'm going to use a random Oracle admin password and set some other properties. What is the port that I want to expose, and some other properties that I need to pass to the container itself. And what GitHub Action does is bootstrap that container and make it available for the lifetime execution of that particular action. So you may have as many steps that try to talk to the database or run a test case or grab information from the database, because that database has been already set up by a service. Here is another option from, this is, I believe, Schema Crawler is a third-party database browser. It's a desktop application. And they too, as well, use Oracle XE, the images from Gerald, to test that their, in this case, their Docker images using Docker Compose are working as they should. Here is another project called jQuickPerf, I believe it is. And this is a unit test that consumes the Oracle XE image plus test containers. It is as simple as it is deceptively simple as the whole point of providing this set of abstractions and these APIs, so that you as a developer have a much easier time, a much easier experience. Just declare that you want to use an Oracle container, point it to the Docker image, pass some parameters as needed, and then once you start the test case, which is what it's doing here in line 42 to 49, this will ensure that the Docker XE, Oracle XE Docker image, the container gets started, everything is working properly, and once that is done, then your actual test case can run. The final example that I want to showcase, this case is actually a fork of the Hibernate project for .NET. So we're no longer talking about Java. This particular project, this version of Hibernate, also has to verify that it talks to different vendors, to different databases. So you see MySQL and Postgres and Fiverr, and of course also Oracle, which, by the way, also uses the Oracle XE image. In this case, they're bootstrapping the Docker images, explicitly using Docker, and once everything is done, then they can run their test cases. I don't know if it will make sense for them to use test containers. I believe it's possible to run it with .NET, or if it's enough to do it like this, because there's no way to test in this particular test case that the containers for each one of these databases have been fully provisioned, are fully ready before we can run the test cases. That's one of the things that test containers will ensure for you. Regardless of the timing, it is possible to use these images in these different ways. There is also the Oracle Autonomous Database, for which there are at least two flavors. There's the regular standard autonomous, you have to pay a license for it, but there's also the always free tier that gives you access to two Oracle Autonomous Database with, I believe, a minimum or at most 200 gigabytes of space. Don't quote me on that, so just browse to oracle.com cloud free, and you can see for yourself all the specifications of all the offerings that we have for this particular free tier. Once you have registered, you can use all the resources available to you for free forever. We're not going to charge you a dime for this. If the kind of applications that you're building require more work, require additional resources or services, then of course you will have to look into the different licensing options that we have for you. But just to get started, you can use this free tier to test out everything that we have. And by the way, these Oracle databases, these 2 instances that we're offering in this version are the real deal. They are not watered down versions of the product. They are the real deal, so you can use it as is. You might recall that I talked about JSON earlier. There is another thing that has come up in, I think it was December of 2021. Oracle announced something that is known as the Oracle Database API for MongoDB. In other ways, this is JSON APIs that can be used within the Oracle database. If you are already using MongoDB and you would like to have reporting capabilities that are kind of hard to come by with Mongo, these are very great for relational tables. Well, what happens if you're able to somehow host your data in Mongo fashion or JSON format inside our Oracle relational database? Now, then you can access and read that data using Mongo APIs, but also have all the benefits that relational tables and relational data give you, all the report capabilities and everything else, every other product from Oracle that knows how to talk to relational. So the end result is that if you are considering to switch to MongoDB or use JSON APIs, give it a try to what we offer with this API. If you are already using MongoDB and if you're, I don't know, reaching out some issues with a scale or you're missing some capabilities, some features, give it a try to our API because it's as easy as changing the URL, the connection URL from Mongo to Oracle and having the Oracle JDC driver as part of your application. If we did our job correctly and we tested this thing every single day, then that's the only thing that you need to do and your application will continue to work. Yeah, of course, at some point, if you already have existing data, you need to migrate the data. It's possible to do that by hand by writing a simple program that uses Talk to Mongo and uses the Oracle JDC drivers through and also the Oracle database API for MongoDB. And that way you can move data from one another. Maybe the case in the future that we offer tools that will allow you to do this. We'll have to check if any of those tools will be available for free. But if that were not to be the case, know that you can also write the tools by yourself. And speaking of tools, there are a few that I would like to talk about. If you happen to talk to the Oracle Autonomous database, you're using a database in the cloud, you need additional set of configuration and permissions to talk to a cloud resource. You can use pretty much any desktop client to talk to a cloud database, but given that you need to take care of extra steps, it would be perhaps much easier if you had a client, a SQL client that is already running on the cloud and that can talk directly to your database. And that is exactly what SQL Developer Web is. So matter of fact, once you log into your Oracle Cloud account and browse into the Autonomous database, there is a button somewhere in the top that says connect to my Oracle database or this Oracle Developer Tools. And one of those buttons will lead you into SQL Developer Web automatically. So the only thing, once you click that button, you have to supply your login credentials, and then immediately you will open a browser. You open a browser window where you can issue queries and do anything that you need to do to that particular cloud database instance. It's just as simple as that. There is also, if you prefer to use command line tools, there is this project called Oracle SQL CL for command line. It is a Java-based project, so you need a version of Java. I think I want to say you need at least version Java 11 to run it. And just like any other SQL client, this works on the command line and will allow you to create tables and query and do anything that is needed. Why would you prefer to use a command line tool over a desktop client or a web client? Well, if you are into DevOps or if you need to just do things quickly without having to boot up a desktop application, you know your way around a command line tool, well, this will be the option. And finally, this is the last tool that I'm going to cover today. We have also offered the capability to expose a database, an Oracle database, to the web so that you can query, you can grab data, you can store data using a RESTful web service, a RESTful web interface. Basically, Oracle REST Data Service is a web application that sits in front of your database. And now, once you have that application running, then any client, any web client can talk using SOAP or REST directly into your database. It's easy for certain kind of use case scenarios. Just use regular REST and you're done, so you can send JSON directly from the client if you want to. You have to take into account that when you are doing multiple mutations, that there is no such thing as a multiple transaction. Everything is done in one go. That is, you issue a query to the backend server, to the REST service, and that will either commit or fail. There is no way that you can sell multiple queries and batch them together. So take care of that. There may be other options out there. This is the simplest way that you can expose certain areas of your database to REST so that you don't have to create that by yourself. You don't have to use the previous frameworks that I showed earlier, Micronaut, Spring Boot, Helidon, Quarkus, and the others. You just can simply rely on an application that has been battle tested by Oracle teams. Again, this particular piece of software is also available for free. I believe that everything that I have shown to you today is either fully available for free. You can start from scratch as is. Only the Oracle Autonomous Database, if there is a free tier, obviously, but there is a licensed version. And most of the stuff that we saw is also open source. The Oracle JDC drivers are not open source, but they are available for free. And thanks that they are finally available to Maven Central, that has allowed third-party members, other service integrators, to create additional tools and grow the community above all of this. So we are very, very pleased and happy that several Oracle teams are working towards making these projects and products ready, available to you, so you can test it, so you can use them for development, so you can use them in production. I will recommend you to go back to any of the sections that we saw today and just go again into the QR codes that will let you browse into particular pages to give you more details about each one of these projects. If you happen to have any questions, you can reach me at any time at my Oracle account. I'm also available online. I am, from time to time, I travel to Japan. I'm really, really happy and keen to engage in conversations with you. So any questions with the projects that we saw today, even the third-party ones, any questions that you may have with any other Oracle products related to the database, let me know. Myself and my team will be very, very happy to talk to you about all these things. If you encounter any trouble, if you have any ideas of features, of things that you would like to see, if any of these things, let us know and we will see a way how we can make things better. Thank you very much for your time. And I will be very happy to see all of you at some point later in the future.